So great. I'm Ben Freas. I'm with Navigant Research. I'm going to talk today about IoT, data, and new business models when it comes to those two converging on commercial buildings. To start off with, is anyone familiar with Navigant? Yeah, okay. We're a global professional services firm helping clients go through transformative change in highly regulated industries. I'm part of the energy practice. Part of our Navigant Research is the marketing research and consulting arm of Navigant Consulting. We cover 4 main areas: utility transformations, building innovations, energy technologies, and transportation efficiencies. I'm in the building innovations group, and that's what we're going to be talking about today, although a little bit of the utility transformations as well. So right now in buildings, there is transformative change. That's, as technology improves, we're going through 3 main stages, first being localized efficiency, then localized intelligence, and then network intelligence. What that translates to use lighting as an example, localized efficiency is the installation of LED lights, reducing the consumption of energy when equipment is operating. The next kind of level on top of that is then adding sensors and controls, making sure those lights aren't on when no one's in their room, or lowering the level of light provided when the light is coming in from the windows. Then the next step is where the data really comes involved. If you're collecting that building data, you can add connectivity to those systems and provide network intelligence to provide even more savings opportunities. When we talk about the technology in commercial buildings that data enables and drives, there's a couple classifications I'm going to use. The first being the building automation system. Hopefully these definitions are familiar to most of you. I'm going to just briefly go through them in case they aren't. Building automation systems are the set of components that are used to control and automate a single building function, such as HVAC or lighting. Building on top of that, there's the building management system, which brings together 1 or more building automation systems and provides front-end decision support for operations. On top of that is the building energy management system, the software layer that is able to use that data from the building to provide analytics and bring in outside data in order to provide decision-making support for for building owners and operators. The top of this chart you'll see is the Internet of Things, which I'm sure you've heard a lot of buzz about. It's connecting things to the internet. Now you'll probably say, isn't that what building energy management systems is? Didn't you just say that it was connecting things and providing value? It is, but IoT is a little bit of a broader business and technology trend outside of just buildings. And in fact, I'd say these are kind of applications of this IoT trend. When it comes to commercial buildings and the technology in these buildings, I think the interesting part about IoT is that, 1, it is accelerating adoption of connectivity by providing economies of scale with other connected devices, but it's also changing the ecosystem and landscape of who is competing to provide technology innovations in buildings. Now, in addition to changes from commercial building perspective, technology perspective, there's also broader changes in the power sector. Traditionally, we have a hub and spoke, centralized generation, centralized distribution of power. One-way power flows, one-way communication flows, traditional model, but that is increasingly changing with the addition and increasing, accelerating adoption of distributed energy resources driven by carbon emissions regulations and such. And that is fundamentally shifting the needs of the power grid and is changing the interactions each individual piece of that power grid has. So that means with the addition of on-site renewable, distributed energy, battery storage, microgrids, you now need both two-way communication in order to maintain grid structure. With regards to commercial buildings, they now are a part of this broader trend of the energy cloud. The backbone of this is really intelligence in buildings. So what that means is smart meters are now needed to better understand energy consumption. There's a fundamental shift of thinking that needs to occur from building owners to change the idea of what a building is, from something that just consumes electricity to something that can actually be an asset and provide services, either energy storage, demand response, as part of an overall network in the energy cloud. That is really going to be enabled by increased adoption of IoT devices, getting data from building systems, and then also the implementation of building energy management systems to manage that data and provide meaningful results. I think, interestingly, this shift in the context of the energy cloud, in order to play well from the outside of the building in, also enables a lot of value additions from within the inside of the building beyond just energy. When you are able to pull in better data, you're able to drive enterprise awareness, you're able to tie business operations with building operations to provide more meaningful impact with the technology investments that you make. Now, I'm sure you probably are aware from the presentation this morning how, in the grand scheme of things, energy consumption is not a huge spend from the corporate perspective. The real estate is typically an order of magnitude more expensive than energy, and then your personnel is an order of magnitude more expensive than that. And I think one of the shifts that better IoT connectivity and data in commercial buildings is enabling is using that data beyond energy applications into these broader business functions. So with that said, that is a great future, but it's not there yet. There are a number of market barriers in order to, that need to be overcome to really enable adoption. Most buildings you'll probably realize are not the smartest, most intelligent buildings. And an important part of this is that a lot of buildings are already built. There are existing systems out there. There's a range of what is installed, how they communicate, and how they operate. There's also the challenge of cost. There's not only does adding connectivity add more to the upfront cost, it also creates additional tasks for people to do. That's from facilities managers to expand the scope of their role, but it's also just when you do add connectivity to a building, you have to go through and make sure that all of your data is collected properly, everything's tagged. It's quite a hurdle to actually get from connecting your devices to getting usable data from those devices. Additionally, there's an expansion of the decision makers and the stakeholders in this process. There's more gatekeepers, whereas building systems had previously been in the realm of facilities management. Now, with increasing connectivity, you now have IT departments who need to weigh in on these decisions, and these different stakeholders often have different goals. Whether it's reduce maintenance, reduce energy, or provide, ensure business operations. There are a couple different solutions to those, and one of them I want to focus around is the as-a-service model as one of the emerging business models. But part of what needs to happen in order to enable that is open communication, open systems, secure connectivity, I guess a heightened awareness of the vulnerability from the cybersecurity point of view, and really the ability to provide scalable solutions. And once those problems are solved, we can really focus on the innovative business models that I'm going to touch on next. So what does an IoT business look like? At Navigant, we have kind of 3 levels of an IoT stack: the device, the applications, and then the services. And each one of those are typically come from, need different capabilities in order to provide value, and are really different methods of thinking in capturing the value with the customers. So device is the easiest to conceptualize. I think with the conversation of IoT, that is where most of the conversation is now. How many devices are going to be connected to the internet? From a device manufacturer's point of view, you can say, oh, this connects to the internet, it has to have value. And from the point of view for internet companies that provide the hardware to connect things to the internet, it's very attractive to expand their markets into adding these 2 devices. But a device connected to the internet doesn't really do much on its own. Kind of the next layer you think about is the applications that are built on top of that. And that's also a shift from strategy from the supplier's point of view, from making sure you have the right product for the right price and kind of focus on the product to focusing on what comes next. The platform, how well it plays with others, what kind of personalization you can provide through those applications, and the network effects that can be gathered from connecting devices. So on top of that, which is what data and kind of the data piece of this IoT and data with changing business models is the services, and ultimately that's going to be the value add of the IoT business case. Just thinking this through in a real-world example, if you think of a refrigerator that can be sold as a connected refrigerator to play with the Internet of Things. The device, very straightforward. Connecting it doesn't really provide you anything, right? Who cares if the refrigerator is connected? If you then have an application on top of that to either set your preferences through your mobile phone or broadcast out to your Facebook friends that you have local cage-free, farm-fresh brown eggs, that is another layer of value. But what really will solve the headaches of people who are making that decision is if you get that knock on the door saying, I'm here to change your refrigerator compressor because it's about to blow based on the data we're collecting and we don't want that ribeye that you have to spoil. So that I think is often lost in the conversation about IoT in general. IoT is really kind of a trend that enables smart companies to provide better value to their customers. Now, another big change in business models over the past several years is the emergence of the as-a-service model. This has come from cloud computing, software as a service, I'm sure all of you are aware of. And I think that this is, on one hand, a way to change how people pay for things. Rather than sending physical copies to be installed on site, you're delivering that over the internet. But it's really more than changing how you pay for things. It's a way of changing how you think about the value you get out of what you're buying. Most people don't care about the server that they get or the storage they get. They care what they can do with it. So by assuring that what can you do with this, it really provides flexibility to the people who are making those purchasing decisions. And then I think on top of that, there is on the note of changing the way you buy things, I think the important things to point out here are that you are shifting capital costs to operating costs, which is important, and also providing predictable, recurring, ongoing costs without having to worry about, when something blows up, how you'll have to replace it. So now I talked kind of broadly about, high level, hope I didn't bore any of you. I'm gonna take these concepts and these trends that are going on and apply them to the lighting market. Lighting is going through transformative change right now with the adoption of LEDs. They're far more energy efficient than fluorescent and incandescent bulbs. There are a number of other features that are really enabling deeper value than just the energy efficiency though. They're inherently controllable. You can easily dim them and they turn on and off instantly, unlike fluorescent tubes, when you cut power. So that enables better sensors and better controls to provide better lighting through there. But on top of that, there's more advanced technologies as well. Network lighting systems, because they take less power, you also have the possibility to deliver through power over Ethernet on one cord lighting as well as connectivity. Which hasn't really reached a lot of market adoption at this point. But even when you're changing out those light bulbs and changing your fixtures to install LEDs, you have the opportunity to, for not much more money, install connectivity to network those lightings and provide additional controls. And the shift to LEDs has really enabled broader adoption of lighting controls. And then you can build on that and provide cloud services, better management, and even visual light communication to use your lighting network as a information network, which either you can use for indoor positioning in retail or other applications, or eventually use Li-Fi to transmit data bidirectionally. So each of these lighting upgrades each of these new technologies each of these value adds that are enabled by the new technology is really enabling new business models in the lighting space. And just as in case none of you are aware of what the traditional lighting space looks like, this is a simplified view of what the value chain is. You have lighting manufacturers that could be two different companies who manufacture the lamp and the fixture differently, or it could be the same. Goes through distributors or agents to an installer, to a building owner, and you could have controls that go through a systems integrator, get installed. It is a kind of structure that has evolved through history to meet the specific needs of buildings over the past several hundred years, or 100 years, I should say, and hasn't changed much until quite recently, where you're seeing some convergence around lighting manufacturers looking at more for including controls, as well as more recently, just consolidation among lighting distributors in the market. Now, the lighting market will change much more quickly moving forward. One of the other benefits of LED adoption is the long lamp life. You can see on the right side of the slide just how much longer that is. And what that translates to is you need to change your light bulbs less frequently. And you see in the left side of the chart is our forecast revenues of lamps going into commercial buildings going out 10 years. And when you need to change your lamps less frequently, you sell fewer of them. So from a blue ocean, red ocean strategy perspective, this is the definition of a red ocean. There's think of shark-infested waters where you're battling for market share and competition is fierce. And even when you just maintain the market share you have moving forward, you're still losing overall revenue. So there's a real motivation from the point of view of lighting companies to expand into something different. And what that something different could be is services. Lighting services aren't new. You need them in order to actually provide lighting to spaces. I guess we break them down into four main areas: professional services, maintenance services, managed services, and other services. Professional services are all the pieces that you need to actually get lighting installed, from design to installation, project management, commissioning. Then the maintenance services are the maintenance agreements. Make sure when they go out, they are replaced timely, and assuring, rather than selling a light bulb, you're selling the presence of light. And then managed services is really the turnkey solution that bundles these together. There's also other services that exists, financing, third-party ownership, and some of those value adds around visual light communication, or some of the pieces of data that haven't really there aren't good examples quite yet, but there are potential to use that lighting data for higher value or additional value to solutions. So these are the areas where we see lighting companies could provide an innovative model to stay relevant. And really what underpins this, because these are not new, is the ability to use data, the increased connectivity of lighting, and the increased presence of sensors to provide these either together or separately in lighting as a service package to use, to provide these either together or separately in lighting as a service package to increase what a building owner or operator can do with their assets. So, lighting as a service. Anyone hear of it already? A couple hands. And I bet if I asked each of you what your definition was, I'd get 3 different definitions from you. There are several people who are out offering lighting as a service in the market right now. They're all doing niche applications for the most part, and there isn't a lot of consensus on what that means. The market is still very early, but there are some common threads that tie these together. There's some form of long-term third-party commitment. They last anywhere 2 to 12 years, depending on what exactly is included in that. The vendor could own the equipment, or the third party can, or the building owner can. I think an important part here is, unlike the software as a service market, the financing isn't as integral. I mean, remember what I said, software as a service was about changing the way you pay for things, but it's also more about that, and more than that. lighting as a service isn't necessarily about changing how you pay for things, but it's definitely about more than that. There's also the characteristic that the lighting equipment gathers data and uses that somehow, and it can include maintenance and other services, but doesn't necessarily have to. So what we're left with is a spectrum of services, with the lighting as a service spectrum. And the way we look at that is we divide it by the service ranging from basic to advanced, and the technology from standard to advanced. And you know, from the solid software as a service business model, that would be really the kind of vertical side on the right, providing the advanced service of the financing with either, you know, just basic technology or advanced technology, but that's not it. That's not all there is. I think there's different versions depending on who you talk to, and the key takeaway from this is that lighting companies need to start thinking about where on the spectrum they will be able to provide a value add moving forward in order to offset the declining revenue from lamp sales. And yeah, I actually am a little early, but I'd love to take some questions and hear from you guys if you have any responses. Oh.
Hi, you said there you saw several players out there already running this model. Which ones are the types that you see most successful? Small, large? What type of customer segments are they focused on? Where this model is actually working in the early stage, early adopter part of the cycle?
Yeah. So there are several, and I think even the players in the lighting market right now, the traditional lighting players, those who don't officially have offerings are probably working on forming that through partnerships or acquisitions or developing those capabilities. As far as the main players who are out there right now, Current by GE is one. They have, in addition to lighting as a service, provide the on-site generation services and so forth. I think interestingly, with their divestiture of GE Capital, they left enough of it to provide financing if they need, through GE Current, if they need financing. That capability they still have. They have a breadth of solutions there. Enlighted is a good one to think about too. They focus on the platform and work with their partners to provide the services, to provide the luminaires, provide kind of analytics on top of that, and they're, I guess a different way to think about lighting as a service by enabling the platform. I know Philips Lighting also has a lighting as a service offering in North America. As far as where they do well, it's still to be determined in my mind. Each one has done well in niche markets, but we're at the point where there's a diversity of offerings that hasn't shaken out with broader adoption.
I probably have, this is probably too basic of a question. We started with lighting as a service, you started talking about energy production, local energy production, and that it powers that energy into the grid, so that when you get solar, that your solar power goes to the grid and then is broadly distributed. And as a cost proposition, would it be cheaper for me just to pay to get 5 more panels put on an existing array and invest into that, and then to put it on my own building, and then have my own transformer and all the other equipment and do the local? Is it, why should I put it on my building instead of invest in an energy plant, I guess is the basis of the question.
So, so for on-site solar PV generation, you want to know, should I build it myself or should I pay my power company or use conversely?
As a value proposition.
Yeah, I mean, I think when solar PV prices have come down a lot, I think, really the way I look at it is, energy efficiency is going to be far more cost effective to implement for most sites than on-site generation. And so, the saying I've heard is you have to eat your energy efficiency vegetables before you get your on-site generation dessert. And so I think from that point of view, it's definitely tough. I'd say the decision about installing on-site generation versus going through, an energy plan, I think should come after the talk about how can I actually save energy in my current operations without disrupting things.
In terms of the Internet of Things, there are several different communication standards out there in the marketplace. Do you see one as rising to the top, or what should people look for if they're
Yeah,
shopping around?
so yeah, I mean, there's several communication standards. You know, the Thread group has Google behind it, and there's Zigbee. I think ultimately, you know, there's the challenge that one that, you know, postpones investment, because with this uncertainty about which one will be around 5 years from now, I might as well wait 5 years before I invest. But I think, you know, there's a good lesson from the residential space, which you're looking at kind of the SmartThings hub and Philips Hue, and these are operating on Z-Wave, on Zigbee, and using just you know, having extra radio chips with software translation. And I think that will probably be in the near term the you know, I guess the bridge to increased adoption is take that decision out of the way by having a deployment that has more than one communication standards with just some translation and a little bit of additional hardware. And then eventually the standards can truly compete against themselves. Because right now the conversation is really, you know, should I invest in this communication or not, rather than which type of this communication should I invest in. So as the market develops, I think we'll get a more sophisticated discussion about these features and which one is better. But in the meantime, I really see, you know, an all of the above network translation approach as growing the market.